Welcome to Unit 5, Part 2. Here we'll talk about medians and altitudes in triangles and what happens when all the medians and all the altitudes of a triangle meet. First, the medians. So the medians of a triangle intersect at a point called the centroid. It means that it is the center of the triangle, and the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So for example here, if you look at AP, it's going to be 2/3 of AK. So like for example, if AP was 9, then 2/3, sorry, let's make it 8. Then 2/3 of 8 would be 12. So the whole thing would be 12. So you know it's 4. So basically it's going to divide it into where one segment is double the other. All right, so how do we use that? In triangle XYZ, P is the centroid and YV is equal to 12. So YV, the whole thing here is 12. So it wants you to find YP and PV. So remember, it divides it into 2/3. So 1/3 of 12 is 4. So that means PV is 4, which means the other 2/3 would be 8. So YP is 8, PV is 4. So number 13, triangle LNP, R is the centroid and LO is equal to 30. So 1/3 of 30 would be 10. So that means the smaller part, RO, is 10. And LR is double, so that means 20. So LR is 20, RO is 10. In triangle ABC, CG is 5. So this part is 5. It wants you to find GE. Well, remember 5 is going to be double the smaller one. So GE half of 5 is 2.5. So number 14, triangle JLN, JP is 16. So half of 16 is 8. So that means PM is 8. Right? Because the part that goes from the centroid to the vertex is 2/3 of the part that goes from the centroid to the midpoint. All right, so let's look at the next one, little coordinate geometry. It says, a fan of a local baseball team is designing a triangular sign for the upcoming game. In his design on the coordinate plane, the vertices are located at -3, 2, -1, -2, and -1, +6. So there's his triangular sign. What are the coordinates of the point where the fan should place the pole under the triangle so that it will balance? So basically you want to find the centroid. So if we look, remember the centroid is going to connect. So like the midpoint here, and the midpoint there. So notice if you connect or draw a line from the vertex to the midpoints, that the centroid would be somewhere right around there, which would be, as an estimate, -1.5 and 2. So that would be the coordinates where the centroid is, and that would be the balancing part of the triangle. All right, so then next we talk about altitudes. And remember, altitudes is a segment drawn from the vertex of a triangle that is perpendicular to the opposite side. So notice they're not going to the midpoint, but they're perpendicular to the opposite side. And the intersection of the altitudes here is what's called the orthocenter. The vertices of triangle ABC are -2, 2, 4, 4, and 1, -2. Find the coordinates of the orthocenter of triangle ABC. You may eyeball it. So if you were to draw or see about drawing the altitudes, so it would be about there. And then there. And up there. Like there. So there's where the altitudes would be. So there is the orthocenter where they meet, right here. And that coordinate looks like 0, 1. So it would be B for 0, 1. All right. So now in triangle RST, RU is an altitude and SV is a median. So that means SV divides in half, whereas RU makes it perpendicular. Find the measure of y if angle RUS is 7y plus 27. Well, since it's an altitude, that means it's a right angle. So 7y plus 27 for part A is equal to 90. Subtract 27. 7y equals 63. So y equals 9. And then for part B, since it says RV is 6a plus 3 and RT is 10a, the whole thing is 10a plus 14. Well, if this is 6a plus 3, then the other side is also 6a plus 3. So 2 times 6a plus 3 is equal to 10a plus 14. So 12a plus 6 equals 10a plus 14. Subtract 10a. Subtract 6. And you get a is equal to 4. So now I want you to find RV. RV is 6 times 4 plus 3. So it's equal to 27. All right, so to recap what we've talked about in the last two videos, the special segments, perpendicular bisector, it basically is perpendicular to a side and divides it into two equal parts. Where all the perpendicular bisectors meet is called the circumcenter, and it's equidistant from the circumcenter to the vertices. Angle bisector is one that divides an angle into two equal parts. The intersection of all the angle bisectors in a triangle is what's called the incenter, and it's equidistant from each side of the triangle. The median, it goes from a vertex to the opposite side and it divides it in half. The centroid is where the medians meet and it divides the segments into 2/3 from the vertex to the centroid, and then 1/3 is left. And then the altitude is a segment that is perpendicular from vertex to opposite side and is perpendicular. And the orthocenter is where they meet. All right, so that concludes our video on medians and altitudes. Stay tuned for part 3.